All right, welcome ACE Chemistry students. We are about to begin our first digital or video lab. And this lab, what we are trying to do is we are trying to determine the formula for a hydrate, okay? So we are going to go ahead and determine the formula of a hydrate, okay? Now, immediately, what you should be thinking when we're determining a formula of some sort is that we're trying to think, oh, okay, this is probably going to have to do something with our molar ratio. And that's going to be exactly it. So in this case, for this lab, what we are actually going to be doing is use a substance that's called iron 2 sulfate. Okay? And remember, this is going to be a case where iron has a charge of 2 plus. Sulfate is going to have a charge of SO4 2 minus. So it's going to be FeSO4. Okay? And this compound is a special compound that in nature will grab onto and hold onto water. So what we do here is we go ahead and say, okay, well, this also has water to it. But we don't know how many moles of water for each molecule of FeSO4, okay? And that's what we're going to go ahead and find out today. And the way that we're going to do that is that we're going to go ahead and weigh this. We're going to drive off all the water, and then we're going to go ahead and reweigh it after the water is gone, and then we're going to use our math skills that we used from before, in particular the determining the formula using percent, to go ahead and help us solve these problems here. Okay, now for this type of experiment, you're going to need a couple of things. First, you're going to need a ring stand with a ring, and the ring stand and the ring may not be put together for you, but it's really easy. It's really just untwisting it and twisting it back on. Okay. You're going to need to have a dry ceramic dish, and this is a ceramic dish. Ceramic dishes are really good for this because they will not, melt or burn or anything like that. You're going to need to have a scupula because you're going to need to grab the actual iron sulfate. And you're going to need a heat source. Now, likely you guys are going to be having this as a heat source. You're going to have a Bunsen burner for a heat source. However, in this class for today, we are going to end up using Matilda because, well, Matilda I could just turn on whenever I want. I have to go ahead and, call somebody to turn the gas on here. Okay, and then the last thing you're going to need is tongs, and you're going to have access to the scale. So the very first thing that we're going to do before we do anything else is we're going to go ahead and make sure that our dish here is clean and dry. Now this one already looks pretty clean, but it is not dry. You can see that I already have some liquid there at the bottom. So we're going to go ahead and clean it. A little bit of paper towel, make sure it's completely dry. Then we're going to take it over to our scale, and our scale is reading at 000, which is what we want. We're going to put it there, and we're going to go ahead and note what the mass of this is. Now notice one of these numbers keeps changing, and it's that last digit. So we're going to go ahead and round our last digit, and we're either going to round that to, either 0 or a 5, depending on, and that's going to be the one that we're going to be a little bit unsure of. But for now, it looks like it stopped, and it's at 41.9210. So the weight of our dish is 41.9210. Okay, and notice it's already gone up 1, but we're rounding that last number there. Okay, we figured out our weight of the dish. Now, I'm going to be perfectly honest with you. The way that they want you to do this will involve weighing the dish. More often than not, if I was sitting here doing actual chemistry, I would hit this button here, and this tare would essentially remake it to 0, and it would make it so that I don't have to do any subtraction math to figure out what the weight of the compound that I'm using is. However, like in your official lab that you may get for this section, they'll probably want you to have the weight of the dish. So now we're going to go ahead and open up, take our dish out, and then we're going to go ahead and put in approximately we're going to put in approximately 5 grams of our substance. And when I say approximately, I really do mean approximately. We don't have to measure it too much and get it exactly at 5 grams. If you had 6 grams, if you had 4.5 grams, either one is going to be fine. You just want to make sure that you have enough of your substance that you can go ahead and do this experiment. Now, when you get your substance, you're going to want to make sure, first of all, that the amount of substance, that the kind of the substance that you get is the really fine parts of the substance. Okay? You have an option. You could see here that we have some, pretty fairly chunky bits of that substance in there. All right? You don't want that. That's going to mess with your measurement. You want to make sure that your substance is as fine as possible. And in fact, if you were at the lab itself and you notice that your substance isn't as fine as you want, you should go ahead and ask for a mortar and pestle so that you can go ahead and grind that down a little bit, because that'll make your experiment better. Okay, so I'm going to add just a little bit more here. All right, so now we have about 5 grams of the substance. And now we're going to go ahead and weigh it out. And, this is both to weigh it to double check to make sure that we have 5 grams. And also this weight is going to be important for us. So our substance, we place it back in our container here. And then we weight 46.532. And that's going to end up being 30. Wait for it. 46.5320. Okay, we're going to go ahead and round that 2 down to a 0. Wait, what did we get? It was 46.5320. Okay, so we now have the weight of our dish. Now we have the weight of our substance right here. We're going to go ahead and come back. We're going to grab our substance. Okay, and we're going to go ahead and place it on this dish right here. Now, the whole point of us putting it here is because now we're going to have a nice safe place to go ahead and heat this up, because water, we know that water has a boiling point of about 100 degrees. So we're going to go ahead and heat it until we drive all that water off. And when we drive that water off, we're going to also expect to see a color change. So I'm going to try and show that to you as well. Now, the key to this lab, though, is, in particularly, since we're driving water off, we want to kind of drive it off slowly, okay? So we don't want to just put our heater underneath and have it just go full blast. We want to drive it off slowly. So we're going to go ahead and, make sure that our heat is being applied and that we apply just a little bit of heat at a time. And then we don't want it all to clump together either. So it's welcome for you to go ahead and stir it around just a little bit here. And you want to be very careful that you don't end up having any extra that stays on this. But stir it around and apply a little bit more heat. Okay, don't apply too much heat all at once. You only want a little bit of heat. Okay, then we stir it around just a little bit. And what happens if you don't stir it around, you'll end up getting a case where you're going to have this all clump up, and it's going to be really hard for you to drive off the last little bits of water because of it. Okay, so a little bit of heat, then you stir it up. This would be a good time to mention that this is one of those cases where this is a class that you should definitely take after watching Harry Potter and the Half-Blood Prince, because right now what's going on is I'm also kind of teaching you some of like the nitty-gritty about how to do these things so that you have the best results. You'll never get something like this in a lab report. Okay, and some of you might be able to even hear, hopefully my camera's good enough, that there's some crackling, and that's still just the water being driven off right there. Now, in just a second, I'm going to go ahead and pull my phone over here. You guys can see that we've already got a nice, good color change, and that just happens because we're driving away the water. Kind of like you're stirring in or working with vegetables that you don't want to burn too much. Though, of course, there are some vegetables you should burn. Some vegetables are better burned. Broccoli is an example. If you don't have a good char on your broccoli, you're just doing it wrong. Those people that like steamed broccoli, I don't even get what you're going for. You get a nice char on that broccoli, gives it a nice texture, gives it some crunch. Okay? Okay. Take off the heat for a little bit. And it takes just a little bit of time here. I mean, as you guys can see, it's been probably a boring couple of minutes here because we're just streaming this as is. But eventually you're going to see that you have a majority of it changing color. And you're starting to get kind of like a dull, boring substance instead of that pretty blue, baby blue substance that we had from before. We're going to go ahead and show you guys right here. Now, this substance right here, as you can see, it's definitely changed color. It's no longer as vibrant and colorful as before. So what we'll do here for just a second is we'll go ahead and take our tongs. We're going to place this on the heat table, okay? Now this table right here and these types of tables are specially designed so that they go ahead and absorb a little bit of, they absorb heat really, really well. which is good because we don't want to put it directly onto our fancy couple $1,000 scale. So we're just going to let it sit there for about 30 seconds. And you're going to want to time how long you have it sit just because you want to keep your measurements accurate, okay? I have a timer on the top of my phone that helps me. Then you're going to go ahead and take it. You're going to hope that your opening's wide enough. And then you're going to sit here and wait until it cools down for just a little bit. And it looks like we have 45.013, and we're going to call it at 130. And this is going to be our first measure. Okay. Now, because we're not all the way sure that we have driven off all the water, so what we're going to do is we're going to go ahead and continue to drive off the water just a little bit, okay? And usually this kind of experiment, you're going to want to do it at least 3 times in order to make sure that you have driven off all of the water. So that means that you're going to go ahead and take your you're going to take your substance, and then you're going to go ahead and heat it again. Okay? And this is just to verify that we're kicking off all the water. Okay? Because that's the only way that we're going to be able to find if we have, gotten rid of all the water in the substance. Also, you guys will probably see the effect of this lamb on the day that I'm doing it, just because I'm going to seem like I'm super unprepared today. Just warning you guys. Well, it's kind of like past the point warning you guys. I'm making a prediction. Oh, we got it. Oh, see, you can still hear some of that crackling. That's still the water coming up off here. And again, this is also one of those experiments that's a little bit harder to do in Florida just because we have so much humidity. But as our leaders like to say, it is what it is. Alright, so we've taken it, we've put it back on the table to cool. Okay. Want to let it cool for about 30 seconds. And one of the reasons that we let it cool for 30 seconds is, one is that we need to make it cool, but also our substance will end up picking up a little bit of moisture from the air. And we don't want that moisture to pick up from the air to vary. So the amount of time we need to keep it on there needs to be constant. Okay? And so now we can go ahead and see that we have 44.79. It looks like we left the door open. Okay. 45.7962. And of course it would change as soon as we make our decision. So 44.793. Looks like that's good. 44.7915. Okay, So I want you guys to go ahead and notice that here we have our first measurement, and we ended up driving off even more water with the second measurement. Okay, so that means that we weren't quite done, and that's perfectly fine. And if you're not quite done with the second one, that means that you need to go ahead and do a third one, okay? And if it keeps going down, that means that we're still driving more and more water off each time. So we're gonna go ahead and do another heating through of it to make sure that we get even more water coming off of there. And this is just like another example of where, good chemistry is like good cooking. It takes time. Which is why, a lot of things that end up being like the really good food end up taking a good amount of time. Maybe not everything. Maybe you don't want to cook a hamburger for too long, but if you're making chili, you need to get those flavors going together. They need to know each other. You want to make sure that cumin gets to know the spice, that the capsaicin is easily flowing throughout. It takes time. Good stews take time. Slow braised pork takes time. The only thing that shouldn't take time is your vegetables. Alright, now some of you may have seen just a second ago, we actually had a piece pop out of here. Okay, so that's something that I want you guys to go ahead and note, that when we do our measurements for this in the future, like we had a piece pop out, okay? What's that going to do to our measurement? It's going to end up causing an error. That's unfortunate and it happened, especially since this is the third recording in it. I'm not going to re-record it because a piece popped out. Okay, so we take it off the heat. We place it back onto our heating table. Okay, and it takes a good 30 seconds again. Okay, and we take it over. And then we take a look at our device, and it's freaking out. 79.0405, and it's going up, up and up and up. Okay, and we're gonna go 44.7935. Okay, so now what we have is we have our data. We have our first measure, we have our second measure, and then we have our third measure. Okay, and notice we have an odd result here for our three measurements. Okay, we were driving off water, we drove off even more water, and then we ended up having this one right here where we had slightly more. Okay. So as soon as you get a result that's similar to this, where you get one that has slightly more water than you had before, that's going to be a good example that what you have done is that you have already driven off all the water and it is actually trying to even grab more water from the air. Okay, so that means that you have already done your task. As soon as you see this, where you have the last measurement is slightly higher, that means that you've driven off all the water. Okay. Now from here, what you're going to do is you're going to go ahead and take these measurements, and you're going to figure out how much water in grams did we drive off. Okay. Then you're going to go ahead and answer the next question is how many moles of water is that? Okay, because remember, whenever we can go ahead and get to moles to compare things, that's what we want to do. And then we're going to go ahead and figure out, all right, so how many moles of FeSO4 do we have? Okay, so just a reminder that this number here, this is FeSO4 and however much water we have. This number here, and you're going to use the smaller of the numbers because, you know, that was your better measurement, is just FeSO4. Okay? So you'll be able to use this number to figure out how many moles of FeSO4 you have. You're going to use this number minus this number to go ahead and figure out how many moles of water you have. And then you're going to go ahead and continue on and complete your lab from there. Okay? Now, one last thing that you want to go ahead and do is after you have done your lab, and you've done your lab portion, you've made sure that that Matilda is all turned off and that you're ready to go. You want to go ahead and clean up your lab, but you want to go ahead and take a note of some things around your lab, okay? So, and just a note on like how the substance will gradually pick up water is that as we have been sitting here, it has been picking up water from the environment slowly, which is why we've had this slow tick up. And this slow tick up will continue on for, well, until it's fully hydrated again. Thanks, Florida. So, that being noted, you should note, especially if it's a hydrate lab in Florida, be like, hey, it's Florida, we have 138% humidity at all times. But you also want to take a look at your lab, okay? So now we have some cleanup that we have to do in our lab. We have our substance, and we are going to make special note what happened, what errors happened in the lab, okay? We saw some pop out from here, and it popped out onto the lab table. So we're going to want to make sure that we note that in our lab, okay? That's going to be one of our sources of error. Also, if we go ahead and take a look closely, if it'll focus, nope. We have some of our compound that is left behind on our scrupula, okay? And even though it's a very, very tiny amount, we only got a couple of granules, that's still going to affect our error. So that's going to be another piece of error that you want to go ahead and include when you do your post lab and you have the question that says, all right, what kind of errors could have been produced in this lab? Okay. So from here, this should be the information that you need to go ahead and complete the lab. This will be the data that you need to do it. I hope that you have a wonderful day and, enjoy science.